and that means that we can slowly start our conversation today. Sharing my screen. So hello everyone. Today myself and Daniel will try to bring the topic of intelligent control systems to you. And we will claim that those intelligent control systems are a way to solve today's manufacturing challenges. So in the next half hour to maybe 40 minutes, we will go through this story of what's going on in the manufacturing industry today. We will introduce a small framework called SMKL. And this framework will be a way to position those challenges and to find the place to start improving the production site. And we can do it in a visual way so that it is helping manufacturing sites to get ahead. And then we will introduce different parts of so-called intelligent system. We will show you that the intelligence is available on very different levels in places that you would not expect in the factory floor. And all of this using certain examples. So that is what we are going to talk today. So very shortly about the current challenges, the ones that we will be talking about, and we will be trying to address them. I think that one of very important items is succession of skills, how we call it. And the point is that due to the aging society, obviously our staff, our skilled workers and engineers are getting older, and sometimes we don't have this quick and efficient way of replacing them. So we are left with a skill gap, and this skill gap is very difficult for companies to address. Then obviously improvements of productivity and quality, they are always the issue. This is always the topic that is relevant for manufacturing companies because we experience a lot of defects in our production. We expect quality problems, failure of equipment, and nothing can be done to avoid them completely. But there are strategies to solve such issues either ahead of time or very efficiently once they happen. And here we will also propose a couple of strategies. And finally, responding to market changes. So I think that the mass production that has become quite successful in the recent decades, I think it's going away a little bit. So these days we are talking more about high mix and low volume production, where people are expecting the products to be personalized, and this affects manufacturing sites greatly. Just to mention the new European Union directive, where all the caps on bottles have to stay fixed, and it's a very small feature, let's say, but it created tremendous costs to the production companies. So those things, unfortunately, create a situation where manufacturing companies are left with many problems. A lot of them are very modern day problems, but they are affecting production sites greatly. So we will be talking about solving them. And I think that to summarize this in one sentence, the idea is to improve by using data from the production site. I think this is clear today that the productivity gains are shifting from the factory's floor and the mechanics of the machines to the perfect use of data. And I think this is not surprising. This is something that has become a main principle of Industry 4.0 already many years ago. But I believe that this is still valid, that the data is the new source of competitive advantage. So we will be talking about this data, and we will be talking about using this data in many different ways, from analyzing how humans are moving and how they assemble equipment in more manual processes. We will be talking about how you can use the data from the actual production, from the actual product. And also we will be talking about the assets. So the machines, the type of data they are giving you, and what you can get from that. And finally, all of this, we are not just getting the data, we need to analyze it and diagnose the problems. And we will show you the way by intelligent systems, intelligent control systems that can help you doing that easier than it was possible before. So I mentioned about the framework, and the framework itself, SMKL, is quite simple because it just gives you the idea how to use the data and how to classify where you are in your data utilization. So generally, of course, it goes from collecting through visualization to analysis of the data up to the optimization of the production processor, for example. So this is essentially the idea. And the SMKL is like this matrix where you have just two axes, and basically every problem in your company, every problem of manufacturing site, you can position it somewhere on the how advanced you are in, let's say, using the data, and how advanced you are in let's say specifying the size of the sample, let's say. So are we talking about single machines that you are able to monitor, or are we talking about the whole factory floor? And this of course depends on your management level, we call it, but obviously it doesn't matter where you are, because you can always move a little bit forward, and it is very important to understand the position, the current position. So this SMKL is the tool to help you make sure where you are and move forward from it. And we will show you ways of moving forward from virtually any level. So it doesn't matter where you are. You're using your strategies, the strategies that will present to move in a more advanced position. And finally, the principle we want to make today is that the intelligent control system, however it sounds, is not the same as programmable logic controller. So the PLCs are a part of the whole equation, but this is not the same. And we will be showing you also the data utilization strategies that are not necessarily used with the PLC itself. So yes, we spoke about those different levels, different strategies depending on how advanced you are or you can be in using the data. So you have this simple view of the factory, where of course it can start from the component level up to the cloud when it comes to using the data. And we will start with the first level, going through each stage up to the whole plants that you can also analyze. So Daniel, would you take over?
Yes, thank you very much, Piotr, and thank you also for joining. As Piotr said as well, so if you look at this picture, you can see all sorts of levels, but you don't have to start right away in a very advanced level. Many times it's already good to have a very quick result and ROI if you start very small and then grow in steps. And that's why Mitsubishi Electric also has lots of solutions in each components that we already have. And I would like to introduce also here on the next few slides a few solutions that we have in our servo systems, in our inverters, in our robots that make your life already easier. And they're basically already integrated, so nothing more that you have to get. And the topics that we address are very specific to each products, to the task basically that they have to do, or typical tasks, let's say. So there's maintenance, of course, predictive maintenance, or also improving product quality or takt time reduction. And I would like to go through them one by one, starting with the inverter. And over here, you can see that, of course, our inverters already know all the details about the internal components. So from capacitors, circuits, or even there's a new corrosion detection inside that will indicate if you are in a harsh environment, when the PCB is close before failure, that you should have to replace basically the inverter or the internal components. So really cool integrated functions already. And of course, also there's AI in almost all of our components already inside. So the AI that is specific for this inverter is identifying the cause of the error. So of course, every inverter also has some errors, may be, for example, some overload or some other troubles. And the AI is basically internally detecting what happened before, what happened after the error, and pinpointing already to the cause that resulted basically in that error. So saving you already lots of time for troubleshooting so that you can get your machine back and running very quickly. That is a very small and quick example of the inverters. If we look at the servo drives, over here it is, let's say, a little bit focused more on the mechanics. So typically, servo drives are connected for belts, gears, ball screws. And by learning the behavior of the mechanics, the AI can then detect, okay, what is the good situation? What is the good production cycle? And when does it slowly and gradually shift into a maintenance or breakdown scenario? So what does it mean? So for example, the ball screw is not properly maintained. Maybe there's some oil missing or whatnot. So slowly over time, there could be some vibrations happening. There could be the torque increased because it's harder and harder to move the ball screw. And all that can indicate a breakdown in the future, so we can warn you ahead of time. And exactly the same thing you can also expect for belts. For example, with the belt tension, there is AI technology also for that, and for gearing when the backlash is increasing. So at the end, you will have a very sophisticated predictive maintenance functionality already in the servo system that comes right with it. You just have to activate it, teach basically the normal situation of your machine after you maintain it, and from there on, you get automatically the warning from the servo system that there's a maintenance having to be done very soon. It's a really cool function here, and I think you cannot be any closer to the mechanics as the servo system over there. And at the last part that I want to introduce are the intelligent robots. So you can attach a Smart Plus card that allows you then also to utilize additional features. So just imagine the robot is nothing else but a hand, but with a hand you can if you imagine right now this kid's toy where you have many different shaped holes, and the kid is trying to put the circle into the circle. It's not putting it exactly in the circle, but wiggles around a little bit and then fits it. And roughly the same you can expect then also from the AI, from the Smart Plus card. So even if there are some tolerances or it's very hard and not fragile, but difficult to fit some product inside, you can do it without breaking it, because now the robot can feel, literally. And of course, also all the internal components that you have there as well, maybe any belts, tensions, gears, and so on, are observed all the time, and you can get automated warnings then for some maintenance. So already, as I said before, 3 cool solutions with AI inside that you can start already from the component level, means virtually no extra investment and quick ROI. Going from the component level to the machine level. So getting basically one step ahead. Here always I have to smile a little bit. Everybody who knows Back to the Future with Doc Brown, so they they are traveling back in time in the first version of Back to the Future, and that's exactly also what helps you when there's some trouble with your machine. Just imagine this. You have or actually I will show it in a video later, but just explaining already a little bit. So if you have trouble with your quality or your machine is stopped, you always come to the machine when it already happened. So you're then sometimes guessing a lot, like what happened, you have to reproduce the error and so on and so forth. So the idea of the system recorder here is that you can travel back in time, see exactly what happens, and do according countermeasures, which of course then affect in, if you eliminate this cause for a bit, for example, for a product quality drop or for machine breakdown, in the future your machine has a better OEE, your quality is better, and yeah, overall improvement of your machine. So this is actually a very nice example over here, where you can see that during the assembly of a pen, the cap was not correctly mounted on it, or not correctly screwed, and there was some error basically. It was all captured by camera. This is what I didn't mention before. Of course, with a camera image as well, or video image, if you go back in time, you have a view of the situation that happened, but you also have all the data that support it, and everything is synchronized, so that even if you arrive at the machine where it stopped already, you can go back and you have exactly the same tools as if you're standing in front of the machine exactly at the point of time where it happened. You could see it very briefly on the monitor at the right side. You could see also the time where it jiggled and the cap fell off. So it was very short, but I think this is a really cool functionality of the system recorder over here. But okay, so this was about going back in time, but I think also maybe going again to this movie topics. There's also Back to the Future, right? So also you want to go in the future, trying to avoid what could happen or what will eventually happen if you don't do anything in the future. And I took this small example here from Formula One, because this is actually also an example where this solution that I introduce here is being used. So you can imagine in a Formula One car, there's so many sensors that and the sensor data is transferred all the time to the control desk. And probably if you're watching Formula One, sometimes you hear that the crew from some team says, please stop the car, because they saw something was wrong with the engine and they didn't want the engine to blow up. Okay, so at the end, what the solution does is it creates you a possibility to make correlations of all your production data. So you can see here on the left side, you have item B and item A. So this could be temperature, pressure, for example. And the correlation of both are then displayed over here. So you have the good correlation where your product has still the good quality, but then of course you also have the abnormal conditions over here. That means if your values, if your process parameters go in these areas, your product, for example, will have a bad quality. Okay, after combining then not only these two items, but many, many more, you can create this correlation matrix basically. And with the MT method, you create such kind of circle around it automatically. That means if everything's inside this area, it's good. Your product is fine. If it goes out, the distance is more, then you will create like slowly a bad product. And you can see the shift, of course, from good to bad gradually, and you can react in time. And on the next slide, you can see like a basic configuration of that. So you're taking all of the sensors, connect them to the PLC, and then on the HMI, you can get this displayed, all these distances. And of course, you will be warned ahead of time when it slowly, gradually increases the distance and shifts slightly towards a bad product. So you can be warned ahead of time, keeping your product quality in the right place so that it's a stable production. And of course, not only you can think about it for productivity or production quality, but of course also for predictive maintenance, because here it's exactly same. The principle that for some breakdown scenario, normally it goes very slowly into, for example, temperature increases, vibration starts, to then rapid increase. And this will be also detected here. And you can not only, as we saw before with the servo systems, for example, go for belts and gears and ball screws, but also for all the other mechanics that are inside of your machine. And the next thing, I think actually this is a really cool new feature of our engineering software. It was just released, I think, a few months ago. So let me explain why I think this is so cool. Again, this is helping you when the machine, for example, stopped or you had some bad quality. And let's say you recorded everything already. So you still have to search for the right moment. And then let's say you have a huge code, like really, really long. You have to go through your code and then see where basically, for example, the sensor didn't turn on, or maybe some value shifted in the wrong direction. And I think everybody would have wished already for a long, long time that you just click a button and you jump directly to this area where, for example, the sensor didn't turn on. And everything can be done here with this new functionality in our engineering software. So I quickly just explain it. You record like a typical cycle of a good product. This will be taken as a good example. When then your production is stopping or you have a bad quality, the AI will then check both and exactly show you in the program where, for example, the sensor didn't turn on. And I think this is really cool and helps to reduce this troubleshooting time by quite a lot. I think I don't have to mention that, of course, it all requires data. And I believe everybody joining today sees their networks here on the right side. So just another information we can connect virtually with any PLCs or any system and collect all the data from the network. All right. I think it's time to move one step further. So we went to the components first, the machines, and now we are going more to the line and plant level. So this is basically where you want to collect much more data, not only from one machine, but from many machines, maybe from your whole shop floor. And So this is a, let's say, much more advanced task that that is required over here. And normally, you are probably using, or you're probably employing many people who are there for quality, who are always checking each day all the quality levels. Of course, you also have, as we heard before, this is one of the troubles, if the experienced engineers go to pension. So how do you then educate the new ones, or how do you transfer this knowledge? So there's also like trainings and so on and so forth. But of course, also you have a quality or somebody who's analyzing the data in real time, and then also saying, okay, we have to shift maintenance here and there. But it's all still using lots of human interaction. So there's still somebody who is required to do these tasks. But at the end, I think we are at a time where this can be all used, or can be all made with AI. And we have a tool for that as well. It's called MaiLab. And the main focus of this tool was to make it as simple as possible to use, so that everybody can basically be a data analyst without even being a data analyst. So you're just starting the software. It's very easy. Start it in your browser. You're selecting with a few clicks what is your intention? What do you want to achieve? So do you want to do quality control, energy consumption reduction? Do you want to do predictive maintenance? And you just load it all with data that you require. And then all the analysis is done by itself. You're checking it, and you even can do the feedback loop over here, doing some action. And I think this is really the great differentiator here, that it's very easy to use. You can define your target, what you want to achieve, and simply by a few clicks that everybody can do, you can start creating your first own AI. And the feedback loop over here, so going back and making some reaction, I think that's what really elevates your machines, your line, your shop floor, because the AI already knows that, for example, in terms of quality control, that your product is slowly shifting away from a good product, slowly shifting away to a bad product. So if you know already the countermeasure, it can be done automatically. And then the AI analyzes it again and says, okay, it's back to the normal condition. So it ensures your quality, for example, in this example, to be very, very stable, and gives you also the competitive advantage here. And in this video, you see a little bit the interface already. So I think it's very modern, all starting in your browser. So you can either do it on your smartphone, on your laptop, wherever it is. You can collect all the data, create your AI. And as I said before, you don't have to be the scientist for it. So it can be anybody. So it's really cool. And staying in the same level here as well. Of course, now we were talking about many solutions that are for a specific topic, but at the end also, so you want your stuff to be informed to do some action. So in terms of, for example, the MaiLab that I said before, okay, it can do automatic actions, but for example, for the maintenance topics, yeah, you have to, of course, inform then your maintenance stuff. If there's some sudden change, you have to stop the machine very soon, or replan, or reschedule the maintenance. So of course, there is also the messenger required that visualizes all what is happening in your machine and your line, shop floor, basically. So so that you know what's going on, you can counteract, and especially that it's available on also smart devices, like your smartphone, for example. And of course, here also in the Genesis, in the Iconics, there's many different AI functionalities also there for graphs and so on and so forth. So very, very competitive SCADA system. And last but not least, I think Energy is something that drives almost everybody at the moment with the high energy costs. And also here with the Eco Advisor, we have a great solution. And I just brought two examples from our own factory. So that was a task given also for our factory in Japan, in Fukuyama, sorry, where energy had to be saved. And using the Eco Advisor and just seeing that with a very low effort already here for the press machine, for example, 5,000 euros, or for a furnace, 8,000 euros could be saved per year annually, while the license is quite cheap. ROI could be achieved already in a few months. So that was really nice. And explaining a little bit about the Eco Advisor, what does it really do? It is collecting all the energy data, but also all the production data, and it's combining them. And with AI, it's pinpointing again directly at the situations where you could save some energy. And therefore you can improve, for example, the program, the process automatically without having the need to manually analyze all the data, then manually, for example, display it and so on. So everything done by AI as well, helping you with in a very short time to find situations where you can save energy. And I think this is also a very good point for your machines at the end to advertise to have a very low energy consumption machine. I think this is one of the points that I hear on fairs that are advertised as well. And here we have a solution where you can optimize it automatically. And the good thing is the Eco Advisor is also very open together with the Iconic solution, with the Genesis solution that can collect data from virtually any data source. So it's a very open solution here as well.
Okay, perfect. Daniel, thank you for that. And
thank you very much.
Yeah, we are wrapping up this seminar, and what I want to say at the end, I think that today we see a lot of investments where companies invest in this high-level data platforms that are allowing manufacturing companies to analyze the data. This is what Iconics can do, obviously, but it is a tip of the iceberg, right? So I think that the ability to start smaller is a very, very powerful feature, so that the AI was mentioned many, many times today, but if the AI is given on a product level, that's a different story, right? Because on the product level, on the component level, you are getting very specific intelligence, very specific to the current needs on that floor. And then slowly you can move upwards and implement more and more advanced data analytics solutions and strategies, because it's not only about the products, of course. So I think that the point is, it is much easier to achieve the ROI when you are able to scale your solutions and when you are able to implement only what matters today and basically observing the improvements. So you are covered on every single step of or the level of the pyramid. But the point is that you can actually start smaller. You can start with the component intelligence instead of investing everything into, for example, cloud-based platform, which it might bring the expected results, but it might not. If you start like this and scale up, your investments are much safer. So that would be all from us today. I think we spent considerable amount of time. If you'd be interested in hearing more or understanding a little bit better the whole concept, here is the QR code. It can direct you to some more information. And as always, me and Daniel are very happy to speak with you about some more use cases. I think there is a couple of interesting use cases implementing AI and other data science methods on different levels. And we encourage you to check it out. So thank you very much, and we hope you enjoy this. Bye-bye.
Thank you very much. Bye-bye.